So for today, if you guys want to follow along, I think that would be a better option. So probably you guys should also open Jupyter Notebook on your system and follow along as I do stuff on my system. All right. So today we'll maybe, if time permits, we'll talk about some keywords, tokens, etc. About what they mean and what in terms of programming and what they mean in terms of Python. It depends on whether we are able to cover that, but we'll start with some things. I'll use some terms. So mostly, I think you guys might be able to get it because most of you have a programming background. But if you don't get it, just note or just remember that term, that something like this is there. For example, I'll say functions are there, and we'll see a very few basic functions in Python. And what is a function? We'll cover that in more detail later, and what all use cases of function are there, what is special about functions in Python, etc., etc. But for today, just remember that there is something like that. All right. So we'll come over here, and now we'll talk about one thing. So let's say you write a piece of code in script. Let's say this is our code over here, which we wrote yesterday, which is print hello world or hello something. All right. When you save this code or when you have this code, this is called as a program. All right. This is a piece of code. This is a program, and this resides or this is stored on my system. All right. Now, when I run this thing, it gets converted to something we call as a process. All right. So process is a piece of code in which is in execution or which is being executed or which is being run by your system. So when we say execution, execution means your CPU is doing what the instructions are mentioned inside your code say. So CPU is executing those instructions. So that's called as execution. And the process of doing that is called as executing the code. All right. So if your code is being executed, so it means, or it is running. So running also means your code is under execution. It means your program is now a process. All right. So what happens in terms of processes, for example, if you start your task manager, you'll see a list of processes. It says processes over there, and it shows you what all your system is doing and how much allocation of different resources is there. Same way, when you write a code and you run it, that code becomes a process and it will definitely show up over here. All right. So you might see terminal, which I have opened over here, etc. also in this window. If you scroll somewhere, maybe on your system also. So that's about a code versus a process, fine. And this code that we run via via the script, and this code that will be running via this notebook or Jupyter Notebook will have some differences. I'll specifically point out things when they really matter too much. But remember, there are going to be certain differences between this versus that. All right. And if we do some big chunks of code inside a Jupyter Notebook, probably if you guys revise it later, it would be good if you guys just do that thing in text editor or maybe PyCharm instead of doing that on Jupyter directly if you're doing a revision. All right. But for simple practice, you can also use this Jupyter Notebook. Now let's start with this thing. So why I started with this thing, that this thing becomes a process, because when you start running this code, initially it resides on your hard drive, but once you start running or executing, everything that's present inside this code will reside in your primary memory, which is your RAM. All right. All the things, all the data that this code contains will be present inside your RAM. For example, this code contains a data which we call in programming languages as string, and it's written in double quotes over here. And this is a piece of data. All right. So it's going to reside inside your RAM. And there is some code, for example, print is a piece of code which will print this particular string on screen, and that's code. All right, that's not data, but everything gets stored inside RAM. So it will have, each program has two chunks. One is your code and one is your data. And it also has other kind of things. For example, it has stack. Stack is also a kind of memory, but all these things are segregation of the different components of your program. It will have a code segment, it will have a stack segment, it will have a data segment. All right, there are few more over there, but your program is divided internally into those kind of things. All right. So now let's say I write a value such as 1. Cool. So 1 is something which we call as integer. So if I just run this thing, it just prints 1 on my screen. And Python provides you a function called as type. All right. So type is a built-in thing or something which is provided by Python. All right, and it is to be written in small. So type type has to be written in small, and since it is a function, functions have a characteristic that you have to write this operator. If you don't already know this operator or this bracket, you have to put after the function, and then you may or may not write something inside the brackets of this thing. All right. So, but if I put type of one, it's going to go and tell me what is the type of this thing according to the Python programming language. All right, and it says the type of one is int, and that seems to be correct. If I go and put another statement over here, which is type of, let's say, -1, again, it's going to be integer or int in terms of Python. And if I run this code, if you notice, you get only one output. All right. It doesn't say int 2 times. It just says int. All right. If I go over here, and I don't know which int it is telling. Is it telling me the type of first one or the second one? If I go and say 1.0, what would be the type of this thing, guys? Quick. 1.0. Is it going to be int or float? Int, float? Any guesses?
Float.
Float. And would it print int or float on the screen?
Both.
It would print float. All right. Cool. Why does this print the result of only the second one? I'll tell you about that, because yesterday, if you guys would remember, I had told that this thing is like an interpreter. It is connected to an interpreter in the background. All right. And if I go and put a print over here for both the type function calls, and this thing is called as a function call. Calling means you are telling Python to execute the code or the operation that this function does, and the operation of this function in Python is to print the type of whatever you mentioned inside the bracket. All right. Once I run this, now it shows me both the outputs. One, it says int. For the second line, it shows float. All right. And in your Jupyter notebook, you have a shortcut. You see that I am in escape mode. If you press L key on your system, then it starts showing line numbers. All right. And if you press L again, line number goes off. So it toggles L key, toggles your line numbers, but you should be in escape mode. All right. Now, if I look at this thing, so your print first line gives this output, which is class int, and your second line gives this output, which is class float. All right. Versus when I had done this thing over here, it was just saying float and int. And there's a difference in output. You see that over here it says out, and over here it doesn't say anything like out or something. All right, it just gives me some result. Cool. Now I want you guys to try these same things on your system. Fine. And also write the same code, this code in a Python script and run that. And this code also in a Python script and run that, and notice what happens. Then we'll talk about what's the difference between this versus your Python scripts and what to expect when you're running code in each of them. All right. Just take 2-3 minutes or whatever you need and try this out yourself, guys. And let me know once you guys are done. I'll wait for you guys to complete this thing, right? So what difference did you notice between this one versus this one? When you ran this thing from script, did it print any output on the screen? You can unmute, guys, that's fine.
Yeah.
Did you get any output for the first, this one, only when you don't put the print statement and you ran it from a script? Was there any output? I guess there won't be. Let's, what happened to you guys, Pratap, prediction delete? Was there any output when you ran this code without the print?
Same output. What are you having?
Are you sure? Let me try.
Yeah.
If I save this script, let's say f2.py.
You are asking in Notepad. Okay.
Yeah, not when I say script. All right. So I typically mean that you have to dump your code in a file. All right. A file with a .py extension and then execute it. All right.
Okay.
And you can do it either from PyCharm. You can do the same stuff in PyCharm, in your this Notepad++ or any tool. Even Spider also works. All right. So try from that and then let me know. Does that work, guys? Now, does it print or not? That's the only question I have. When you write this code, does that print anything or not? The difference between this versus the previous one.
Same output as Jupyter Notebook.
Sorry, couldn't get you.
Yes, same output as Jupyter Notebook.
So if you look at these two codes, so if you don't put any print inside this code, when I run this file f2.py, look at my screen, and it doesn't print any output. It just prints a blank line. All right. Whereas if I go to this file f3.py with the print inside it, this thing actually prints something on the screen. All right. So, and whereas if you do the same thing in your Jupyter notebook, it gives me the output of the last statement. And it also says a special thing when I am not putting print, it says out something. Whereas if I put print, it prints both the outputs just like you get on the terminal, and it doesn't say something like out. All right. So what's happening over here is when you run any piece of code from your scripts, only those things are going to get printed on your terminal or on your console or on your std out or standard output. So this is also a term. There is also a term which is called as std out, std err, and std in. There are three things actually. Probably we'll talk about them gradually, and they typically refer to your standard input, standard output, and standard error. So if you run a code from here and it prints something, so that print or the output that it generates, it's going to go to the std out, standard output. And right now my standard output is this terminal, means whatever gets generated by the code, it will appear on this terminal or on my screen. The standard output can be any output device. It can be a screen, it can be printer, maybe something else. All right. So right now the standard output device is this terminal. So whatever your program generates on std out, it comes over here. Fine. And std input or standard input is what, from where or how your computer or your program or your process is going to take input. We'll see input function later. So then we'll talk about it. So when you run a program from a script, it's only going to print the things which you explicitly print using print or some function which puts your output on the std out. Otherwise, you're not going to see anything on the screen, and that's why there's no output from this program, because there's no print statement. Whereas if you do the same thing on an interpreter, Python, you would notice that whatever you type, the interpreter echoes it back to you immediately. All right, there is an immediate feedback. If you say type of, let's say 10, it prints the result of this thing on the screen immediately by itself. And when we look at Jupyter Notebook, this also does the same thing. It's like an interpreter. So anyways, if you type something like print bracket, let's say 10 on your interpreter also, it's going to print that value. The same thing is happening for this case, which is the last one, print type 1 and type of 1.0. But for the previous one, the thing is different. It is working like interpreter, but since in the interpreter, you'll only get the last output or the output of the last command, which is getting printed. So that's what shows you the output of last command, which is type of 1.0. So first it executes this, there is an output which is discarded. Then it executes this, there is an output which is discarded. And only the last one, sorry, my bad, the last one which is there, only that command's output is displayed on the screen. And since the last command is type of 1.0, it just says float. All right. So to print something explicitly, you should ideally use print. And if you just have one single statement in a particular cell, then you can put it without print as well, just for the, like if you're trying out something. Cool. But if you're working with scripts, if you want to see something on screen or the result of something on your screen, then you need to put a print. Make sure that that's clear to you. Cool. Fine, guys. Now tell me if you guys have any doubts about this thing. So this is behind the scenes connected to an interpreter, and that's why the behavior is like this. So whenever you see this out, it means it's coming as the interpreter output. And when you print something, that's coming from your std out. Cool. Now, next thing is we started with this type option or the type of something. All right. And when we start talking about types and memory initially, in the first session, so we were saying that integers on certain systems take around 4 bytes to represent or store your data. All right. In case of Python, there is no limit to the size of the default integer type that it provides. You can store any integer inside Python. There is no limit. So if I go and say C++ data types, let's say the range of those things, and if I go back to that same page, which we saw initially, so if I look at the integer type, and if the integer is taking 4 bytes, I cannot store a number larger than this or smaller than negative of this. Cool. So if I go and I say print this thing, this works pretty fine on my Jupyter notebook or in Python. And if I add more digits to it, it just works because there's no limit to the integer in Python. All right. So now the question comes, how much memory does an integer take inside Python? So the answer to that is we don't know. We literally don't know. If I don't know, you can also say that you don't know. You don't know how much space an integer occupies, or if you store a number or you write a number inside Python, it is going to take in memory. We don't know what space it's going to take. Python is automatically adjust the space, increase or decrease it based on how big the integer that you're using. For example, if I just say print 1, Python might be storing this in 1 byte, 2 bytes, 4 bytes, or maybe more than that. But I think Python will optimize this and probably store it in just 1 byte instead of storing it in 2 bytes or maybe more. But for bigger numbers, which cannot fit in a certain limit, let's say of 2 or 4 bytes, it would probably allocate storage which it can automatically scale up or down as it needs. All right, so there's no fixed size of integer type size in bytes for integer type in Python. That's something important to remember. All right. So is this good or bad? What do you think about this thing? So in other programming languages, what you would have to do is you would have to take care that when you are using an integer of 4 bytes, you don't overshoot the value or the range of value that it can store. For example, if you want to store this number, you cannot use a normal 4 byte integer. You will probably have to go to something like long int or long int. All right, so you'll have to take care of that in those programming languages. But in Python, if you just write a number, it automatically assumes that it is a bigger integer and how much memory it requires. So do you think that's good or bad? What do you just, any guesses, guys? Anything works? What's your notion of this? Is it good? Why it is good? If it is bad, why is it bad? All right, something on chat. It's good. All right, it's good for whom? And why is it good? Is it good for you as a developer or the person who's writing the code? Yeah, but okay. For organization having tons of data. All right. So when we all right, can be used for image processing. Actually, the thing is, when we say organization having tons of data, that data is not going to reside on your main memory. It's going to probably be stored in files or some kind of secondary storage. And when you need it, you will retrieve it or load it into your memory. All right. But don't you think it's so I'll put it like this. From a developer's point of view, it is good. The reason is because I don't have to worry about range overflows, etc. Python will automatically deal with all those issues. But from a systems point of view, it is not good. Why? Because when you have a fixed size integer, if you would remember, I had talked something about word size, etc. So if your word size is 8 bytes or your system allows 8 bytes of memories to be operated directly upon, if you have an integer of 8 bytes maximum, then you can add two integers or do certain operations, multiplication or all the arithmetic on it directly. But to provide you with a variable sized integer, Python has to do some extra stuff, and that extra stuff costs two things. One is time and one is memory. So it's good from a developer's point of view. You don't have to worry about it, but from a performance point of view, it's not good. All right. So we'll later study that your Python uses NumPy, which is written in C programming language, and it uses fixed size integer type. Why? Because it performs better than this, and that's what is used for image processing also. All right. So for those kind of applications, it's better to have a fixed size of data so that things can be done in parallel, or your GPU can perform operations in parallel. All right. So this is good from a programming or code perspective, from writing code perspective, but it's not actually practically performance wise good, both in terms of how much space it takes and how much time it takes for processing these kind of integers. Cool. Remember this part, guys. So it's good, but it's bad as well. Fine. So that's about integer. So there's no fixed size. We don't know what is the size of this thing, how much memory it takes. All right. And we don't worry about that in Python. And when we have to worry, we start using libraries which have a notion of fixed size, like NumPy, that the integer is of 4 bytes or 8 bytes over there. And you get multiple options. You can use 1 byte, 2 byte, 4 byte, or 8 byte integer. You can pick from a range, depending on how your data is. Cool. So there is always a trade-off. Ease versus performance. Remember, whenever you're writing code. Any questions right now based on this? No? All right. So now let's look at something like this. Let's say I write 1 plus 1. So I have been writing it since the first day. All right, this is the first code I ever write, and it gives me an output of 2. All right. If I write 1 plus 1.2, what's going to be the output of this thing? And of these 2 lines also. You guys can unmute and tell me, like, what's the output of line number 1? It's very simple, I know, but if you guys speak up, it would be better. What would line 1 print? 2. Line number 2 prints what? 2.2. And what does line number 3 give me? Sorry, int. And what would line number 4 give me?
Float.
Oh, all right. So the result of addition of an integer and integer is integer, but if you add an integer and float, the output is float. All right. And would this work or not is another question. Can you add an integer and a float? Yes, you can add. All right. That's a thing which is valid according to Python. Python says that you can do this operation and it would work. And this is the output that you guys agreed upon. Cool. So I think this should be easy to understand. And now notice the way I have written this code. That is also important, specifically for people who have not written code or don't understand code much. So what Python does, or what any programming language, or how your program is going to get executed is also important. So always your execution of code flows from top to bottom. So that's why when I ask you the output also, I ask you what's the output of first line, then second line, third, then fourth. I never ask you what's the output of fourth, third, second, and one. Because your computer or what your Python interpreter is going to do is it's going to read the first line, then the second line, then the third line, and then the fourth line. If I miss or if I do some error inside any of the lines, so what it's going to do is it's not going to execute the remaining lines of code if your code has some bug in the middle, but the previous lines of code would execute normal. All right. So it always goes from top to bottom. Later we'll talk about your conditional statements and your jump statements, etc., your loops and if else. There you will see that it comes from top to bottom, but at certain point of time, you can ask it to jump back to top and start again, or certain point above the current location and start again from there. All right, and repeat certain piece of code, but the default execution always starts from top to bottom. So we'll talk about tracing and dry run later, but that's how you try to understand how your code is working. You would start from top to bottom and just do that. Another thing is, if you notice inside this code, I have written print bracket 1 plus 1. So whenever you write something in bracket, just like how you have oddmass or something in mathematics, the first things in bracket are solved and then the outer things work out. So what it is going to do is the job of print is to print whatever is inside bracket. But what is inside bracket is not a simple thing. It is an expression. So these kind of things which generate a value like 1 plus 1, these things are called as expressions. All right. So this thing generates a value. Or let's call it as a result. So anything which generates a result or a value is called as an expression. So this thing is an expression. So what Python is going to do is it's first going to solve this expression. Whatever is the result of it, that is going to get printed. So that's why it prints 2. It doesn't print on screen 1 plus symbol and 1. It doesn't print that. All right. It prints this. Also, I can put any amount of space in between these things, even between this, and it works out fine. But if you put a space before code, it won't work because Python is, oh, my bad. This is interpreter, so it will work on the interpreter kind of thing. But if you do the same thing on a script, it's going to give you an indentation error. I think on interpreter also, if you do it like this, yeah, it says unexpected. because I think when you put this on the first line spaces, I think Jupyter Notebook automatically removes the initial spaces from it. So it just works out. Whereas if you try to put any space between the code, all right, before the code, it's not going to work out well. So Python is a space sensitive language. Spaces are important, but mostly right before the beginning of code, they have a special meaning. If you put something in the middle of code, it's fine. So sometimes, or mostly, you'll see people putting spaces at certain points in code for more readability or more clarity. It's not the syntax or grammar of Python that you have to put a space in the middle of code. It's just for the sake of more readability. People put space, but if you see space being put before code, it's for a special reason in Python. All right, and if you misuse it, it's going to give you what you already saw, which is called as a syntax error. Syntax error is something like grammatical error in languages, like when you say my name is Gaurav. So in this case, there is a grammatical, or I just say, let's say my name is Gaurav, and I put a question mark at the end. So I'm not asking a question. So this thing is grammatically wrong. And also I haven't put the my as capital, and my name is, since names have to be written with capital alphabet, so I haven't written them in capital. So that was also a mistake. So these kind of mistakes are called as syntax errors or grammatical errors. So what grammatical errors are in normal languages is what syntax error is in terms of programming. Syntax error means you're not conforming to the grammar of the programming language, and hence your code cannot run. So if you see that the output of the first statement also didn't come out. So if there is a syntax error, for example, if you forget to put the bracket, all these are syntax errors, but now this code has two syntax errors. One is the indentation error. If I fix this indentation error, it's going to give me another syntax error, invalid syntax. All right. So I have to fix all of them in my code. And once I fix all of that, when the grammar is correct, it will start running. But your program can crash at runtime also. That's a different case. We'll talk about it later, but that's something to remember. Cool. Now coming back to this thing, so I guess you understood what's happening over here. So we have print a function, and inside the bracket there is an expression. So first expression will be solved, and then what print does, it will do it. In this line number 3 and 4, there is even more nesting, or there is even more deep function calls. So what it's saying is print what? Print the result of type of something. Type of what? Type of 1 plus 1. So first it is going to solve 1 plus 1. It gives a 2. The type of 2 is then going to be what? Integer. And that integer is going to get printed by print. So it evaluates inside out, not outside it. All right. Remember, inside out means it will first solve the innermost bracket, then the outer one, then the outer one, and then it's going to give you the result. Same thing happens over here. Instead of getting a 2, you get a 2.2, whose type the type function reports as float. That float goes to print, and print prints that thing on the screen, and hence this output looks like this. Is the order of evaluation and execution clear to everyone? I think few of you would already know about all of this, or it might be very intuitive to you, but this is something too important to remember, that the execution goes inside out, and there is a particular priority of things which we'll talk about, operators and stuff. Then we'll talk about them in more detail, but this is a basic idea about the syntax and some things that you will find varying from situation to situation or person to person writing the same piece of code in different ways. Cool. So this is an expression, and this is a function call, and this complete thing, this one entire line, is called as a statement. Statement means an instruction. An instruction might be a combination of multiple expressions. All right, so this is an instruction or a statement, and different statements in Python have to be written in separate lines. Cool. Except for some cases. For example, in many programming languages, you have to write code something like this. Let's say I leave this over here. Let's say print 1 plus 2, and print, let's say I put my name over here, and you have to write code like this in Python. So if I run this code, is it going to work or not in Python with the semicolon? So this symbol is semicolon, and yeah, would this work out or not? You guys can try on your system and tell me, does it work or not? Works on my system at least. What about your? So yeah, in Python, it's not important to put semicolon. So what semicolons do is semicolon is basically used in those programming languages to tell Python or that programming language that, okay, this particular command is done, or this particular statement, as we call it in programming languages, this particular statement is finished. It's like the full stop. That sentence finishes here. It tells you just that. All right. And after semicolon, whatever is written is the next piece of code. So in those languages, you can write things even like this. All right. So this thing works. If I go down and put this, even this thing will work. You can write multiple statements in the same line in Python if you use semicolon, but semicolon is something you will probably never find or very rarely find being used by people. Typically in Python, instead of using semicolon, Python says that if you write two pieces of code or two statements in separate lines, they are two statements. You don't need to put a semicolon, which is like a full stop in programming languages. You don't need to put a semicolon at the end of each statement. You can just separate them by lines, and each thing is a separate statement. But if you don't put a blank line, a new line, or you don't write your code in new line and you write like this, it's going to give you an exception, or it's going to give you a syntax error, let's say. All right, because this is not valid according to Python. So you won't ever find people using semicolon. It's very rare people use semicolon. Sometimes people don't even know that you can use semicolon in Python, but it's possible to do that. All right, that's another thing. So Python allows you to use, let's say, I'll put that as a comment. So if you notice this code, there's another thing over here. If you see in this particular cell, I have written something starting with hash, and you can see that your Jupyter notebook, my Jupyter notebook, has highlighted this thing in a different color. So these things which start with the hash symbol or the pound symbol, yeah, the hash symbol, they are called as comments. Comments is something like you want to tell something in your code, but that's not code what you're writing. It's like some theory or some explanation of your code, and you don't want your Python program or your Python interpreter to execute or take that into account. It should just ignore it. This is for the reader of your code. So those things are called as comments. So this thing is a comment. So whatever you write on the right hand side of hash is treated as a comment. So this is a comment. All right, and you can put multiple comments or multiple information things at multiple places in code. Whatever is on the right hand side of hash would be a comment. So you can also write something like, so what I was explaining is in Python, we can use semicolon, but it's rarely used. Instead, Python relies on line breaks. So this thing is also called as line break when you write your code in next line to identify individual. I need to close this chat. Individual statements. All right. So this is the idea. And another interesting thing is if you write print bracket 1 plus 2 and you want to put a comment in the same line where you're writing code, so you can put a hash after your code, and since whatever on the right hand side is the comment, so this is still code, and sorry, this part on the left hand side, and what you write after it is this is a comment. So it won't matter what you've written after this thing. But if I remove this hash and I run this thing, it's going to give me an error because you cannot write random stuff anywhere inside Python. All right, so this is the idea about comments and some small snippets of code. And yeah, tell me if you have any questions right now based on all that we have seen. Anything? Do you guys want to try it out, some things on your system, let me know. I'll pause for a bit. You can try out by the time. Otherwise, I'll move forward. Shall I wait or continue? Continue. All right, cool. So let me know. I think this stuff might be very basic to you, but all right. Is it really very basic? That's the idea, actually, to keep it very basic for now, because gradually we'll dive very deep into complicated stuff. Probably in 3 weeks, we'll be on a different level. But yeah, this is something. Maybe it will help you guys understand how Python is doing something or why Python is doing something when you expect it to do something else. All right. So we have talked about type, so and print. We have used two things till now, type and print. Type tells you the type of something, and we have seen the type of two things till now. One is your integer and one is float. And we have been using these text things till now as well. So we can check the string type over here. So if I go and say print type of this thing, it's going to say str, or what we have the class for storing strings or text in Python, which is your string class. So whatever you write inside quotes is going to get printed out as it is, and you guys have to tell me what is going to be the output of this thing. What will it print on the screen? Line number 3. Quick. I think it's simple, but still, I want to just know.
String str only.
It's going to print str. All right. Why? Because this is a piece of text. All right. It's not going to be evaluated as an expression. It's a string. It will come out as it is. Cool. So that's sometimes people mess up, just for clarity. And I think that's pretty much good over here. Now I want to talk a bit about what we call as variables. All right. So what happens in programming languages is, last time we were talking about memory and addresses. So whenever you're storing some data inside memory, it is stored at a particular address. All right. And to use it, or to tell Python that, okay, read data, you have to use it by using the address of that particular data that you have stored. For example, if I want to store the value of this 1 plus 2 somewhere, and in a particular memory address. So if I have to reuse it later, I'll have to call it by the address. All right. But in high level programming languages, or what programming languages do is they internally manage the address stuff. But on a high level, they give you a notion of what we call as variables. I think I have written this. Yeah, now this looks correct. And they give you a notion of variables. So variables is just like the variables you have in Python, X, Y, Z, A, B, C, D, etc., etc. And you can write something like X equals to 1 in Python very easily. And what this does is it creates something by the name X, and that X currently refers to this value, which is 1. All right. So the data that X is holding right now, or the X is pointing to right now, is what? 1. So if I print X, it's going to say 1. And if I say print X plus 1, it's going to do what? It's going to give me 2, because it's going to take the value which is, sorry, my bad, contained inside X, and it is going to add 1 to it and give you the result if I instead put 2. So this thing will also work. And if I go and check the type of X, what is it going to give you? It's going to give you an integer, or say class int. Why? Because X is currently referring to an integer or integer type. Cool. And another interesting property is that I'll just show you. So if you say X equals to 1 over here, and then you say print X, and then you say X equals to 1.3 over here, and then you say print X. So will this work in Python or not? Yes, no?
Right.
Yes.
Yes. All right. And do you know what this property is called? This is called as dynamic typing. All right. Not exactly what this particular feature. So what dynamic typing means is that the type of your variable, or the thing, or whatever variable you are using, is dependent on what kind of data it holds. All right. And the data automatically determines or changes the type of your variable. You don't have to explicitly type something like this in Python. For example, in C or C++ or Java kind of languages which don't have dynamic typing, over there you would have to write something like int X equals to 1 with a semicolon. And when you write this, now X can only hold integers. You cannot reuse X to hold what? Floats or strings or anything. Whereas in Python, you can do this dynamic typing stuff. Dynamic typing means the type of your variable, is deduced automatically from the data it holds. All right. And you can change it dynamically, automatically. And That's what dynamic typing is. The type is picked from the data. You don't have to explicitly say that it is an integer. Python will automatically recognize that it's an integer or it's a float, or maybe it's a string. We can even do something like this. So right now we had put integer, then we put another numeric type, which was float. Can we put a string over here? Yes, we can do that as well. We can put a string over here and it would all work out fine. Why? Because Python is a dynamically typed language and it automatically reduces types. You don't have to specify the type. So in other programming languages like C, C++, or Java, you would have to write this. And once you have written this, in those programming languages, each variable is associated with a type. All right. And what is a type, or let's say data type? We'll talk about it in more detail at length. But for now, just remember there's a thing called as data type. It tells you what kind of data it is. All right. And when we say what kind of data in these programming languages, it tells you how much memory it takes. So if you say integer, in this case, it's going to take how much memory? It's going to take 4 bytes. All right. Let's say then we say double, which is the equivalent of float in those programming languages, or a bigger float. Then I say double y equals to 1.5. So this is going to take how many bytes? This is going to take 8 bytes. Whereas this is going to take how many? 4 bytes. Now, since in those programming languages, your variables are bound to memory, if you want to store a double inside an integer, is it possible? No, it will overflow. It's like you have a bottle of 1 liter and you want to put 2 liters of water inside it. It doesn't just work out. All right. And same thing, because of this reason, you cannot, you don't have dynamic typing in those programming languages, because the type is bound to memory, or the variables are bound to memory over there. In case of Python, when you say x equal to 1, let's say this integer takes some memory, it is stored in memory, and your x is just pointing to that memory. X doesn't have its own memory. All right. Whereas when you say x equal to 1.3, this x now starts pointing to this 1.3, which is stored somewhere else. So x doesn't have any memory associated to it. Same way, when you say x equal to ABCD, it forgets about the 1.3 that it had previously. Now it knows that it has to point to ABCD, and now it is ABCD, or it is a string. And that's what happens in Python with dynamic typing, which is not there in other programming languages, just to give you an idea about the contrast. All right. Does this sound good? Is this clear? Fine. Let me know if you guys have any doubts, or you think of something else is correct, or you don't get this thing. Next thing is, in these programming languages, since your variables are bound to memory, you can check the address of a variable and it doesn't change as you change the data. For example, if you say int x equal to 10 in such language, and after that you say x equal to 20, since both are integers, this thing would work out, but the address won't change. But if you do the same thing in Python, let's say x equal to 10, you say print id of 10. So id is a function which is used to check the address of something in Python, and it is available in C Python. It might not be available in other, sorry, not address of 10, let's say address of x, and x equals to 20, and then I say address of x again. So it's going to tell me two different addresses. Why? Because in case of Python, your memory is not associated to the variable, it is associated to the data. So when you say x equal to 10, Python goes and takes up some memory, stuffs a 10 inside that memory, and then tells x, like, you need to point to this memory, which is containing 10. Then when you say x equal to 20, it creates a value 20 in memory, in some new memory, which is independent of 10. And now it tells you, that tells x that now you have to point to this memory. All right, so the address changes over here. And that's how Python works internally. Like C Python works internally. Your variables are just pointers or references, what we talk in terms of programming, these two terms, pointers and references to data. They don't actually contain the data directly. That's why Python this is how Python is able to support dynamic typing. That's why the data type changes automatically based on what data you are pointing to. So if you point it to a float, now, since it just has to point to that variable, it will just work out without any issues. Cool. If I say 2.03, you can see that the address is actually, this is very different. All right. So there is a reason for this also, but consider these are valid memory addresses, and you can see the difference, what that happens when you start assigning it different values. Because in Python, variables point to data. They don't have their own direct associated memory, in which you will copy the data. Whereas in those programming languages, Java kind of thing, when you say x equal to 10, the memory associated with x contains 10. When you say x equal to 20, this 20 gets overwritten. Fine. So now, if I look at this code, it executes from top to bottom. And if I go and say print x inside this cell, what is it going to print? Is it going to work or not? Two questions are there. Is it going to work? And if it is going to work, what's going to get generated?
Yes, it will work. It will print 2.03.
Sorry, what the level?
It will work and will print 2.03.
2.03? That's correct. All right. If I go up and what variable we are using, x. If I run this code now, find this cell, and now if I go over here and I run this cell, what is it going to print?
ABCD, I think. Last one is
Correct. And why is this happening over here? Because this is running from an interpreter. All right. Because in an interpreter, if you say x equal to or x equals to 10 or 1, then you say x. What is x right now? 1. Let me zoom in a bit. Let me know if at any point of time things are not very, font looks smaller to you. All right. And if I say x equals to 10 or something, then I check x, it's going to be this value. If I say equal to 20 or something, it's going to be this. But if I check x, it's still going to be the last value that I assigned to it. And since this is connected to an interpreter, so whatever you run, it gets stored over there. Fine. Now look carefully. If I go to this option, which is kernel restart, all right, it is going to, yeah. When I restart, this will restart the kernel. You see kernel created, ready, connected, etc. Now, if I go and I run this code, it gives me this error, name error. Name x is not defined. Why? Because when you restarted the kernel, it is like you go to this interpreter, you exit it, you kill it. Now you run it again. Now you check x, it is starting fresh. There is no x over there. All right. So it is the same thing that happened over here. Does that give you a good idea what's happening? Because x doesn't exist now. It got wiped out. So whenever you run a program, the contents are loaded or whatever data it generates, that keeps getting generated inside the memory, or it gets stored inside your primary memory RAM. Once your program closes or your process closes or exits, all that stuff is gone. That's wiped out. And then when you run it again or you rerun it, everything starts from fresh and everything has to be created again. Cool. And if you ever want to run some piece of code in your notebook completely from fresh, you can say restart and run all, provided there is no error in some cell in the middle. So it restarted it and it started executing all these cells. So it ran 1, 2, 3, 4, 5, 6, 7. It tried to execute everything. And since there was no error inside any of these cells, so it reached till the end. And what output it gave for the last cell is what was the last value of x. Cool. So this is something to remember about your Jupyter notebook, that things which you have already created might impact your current code that you are running, because it keeps track of things. All right. That's one thing. So which all functions have we seen, guys? Now, one is your ID, one is your print, and one is your type. All right. So ID tells you the address of something. Print is used to print on screen. Then your type tells you what we call as the tells or returns the data type of what you write in bracket. And there is ID, which gives you the memory address of what you put in the ID. All right. These are three functions that we have seen. Right? Right? And we can club or combine these operations in different ways. We'll see what else can be done. For now, tell me if you guys want me to go through anything again. Otherwise, we'll come to tokens and all, and then look at this thing again from that perspective. Is the notion of variables clear to you in Python? So variables are just some names that you can use to point or you can use to refer to data. All right. And you can use variables inside expressions also. For example, you can write x equal to 1, y equals to 2. These are two variables now. And you can say z equals to x plus y. Then you can say x equals to x plus z. And then you can say print x comma y comma z. So till now we were printing only with a single print statement, having a print statement having only one thing. Now we have put multiple things separated by a comma. And what would be the output of this code? This should be easy, but I still want you guys to tell me what would come out on my screen. Quick guys. Sorry.
423.
423. So what's so let's look at it in this way. So I'll also talk about dry run, all right, or tracing. So what your computer does is we have to be as dumb as computer to understand programming, all right, or maybe algorithms that you might study later, data structures and algorithms. Be as dumb as a computer. So there are three variables over here. First, when it comes to line number 1, it says the value of x is 1, all right. Then it comes to line number 2 and it creates another variable which says y equal to 2. So the value of y becomes 2. Then it comes to the next line, it says z equals to x plus y. And what this does is this has two parts. So this is equal to operator. It's like plus. And it's not, sorry, not like plus, it's an operator. Plus is also an operator. And what it says is store the thing on the right hand side under the name which is mentioned on the left hand side. All right. So this says store the value 1 by the name x, value 2 by the name y, and what is on the right hand side can be an expression. All right, can be an expression means it can be generated value also. So x plus y at 1 plus 2 gives you what? 3. So z becomes what? 3. All right, but does the value of x or y change? No, it stays as it is. Why? Because z is written on the left hand side, so the value of z is going to get impacted, not x and y. Next thing is you say x equal to x plus z. So what is the current value of x right now, which is 1, and 1 plus z, what is the value of z, which is 3. This line is going to update the value of x to what? 4. So that was correct. And these things stay as it is. These don't get changed. Why? Because you haven't done anything for them in line number 4. Then when you come to line number 5, what is the latest value of x, y, z? It is 4, 2, 3. So this comes and that's the idea. So whenever we are trying to understand the output of something, you always have to do a dry run or a trace of that thing. All right. Yes, does this sound good now? Understood? Or if you have any doubts, let me know. Vedang, your output seemed to be wrong, but do you understand it now? All right. So cool. So always follow this habit of doing a dry run or tracing. So what dry run means is you have to think like a computer and keep track of all the variables and see how your program is modifying them. So this gives you the best understanding of any programming language or logic. All right, because logic is independent of programming languages. Once you understand logic, you can understand any programming language. So this is important. So tracing. So we'll do a lot of tracing gradually once we start trying a bit of some very simple algorithms or very simple logic cases with loops, etc. But this is what I'll typically be doing. So normally we do it with a piece of paper and pen. We take a pen and we write all the variables on paper and keep updating them and keep reading the code. And that's how things work out. Fine. So this is the notion of your variables. Somehow. Now let's come to this thing. All right. So what this thing is going to basically tell us is the building blocks of any programming language. So just like when you study any spoken language or any language that you speak and write and talk to people in, like English or any language, what you initially start learning is alphabets and numbers, the symbols that are used to represent them. How is A drawn, how is B drawn, and how is C drawn? Because to talk with people, you should know that when someone is saying A, they mean this, and when someone is saying A, they don't mean this, because this means B. Or what's the notion of thing which is common to everyone? All right. Same way in programming languages have their own syntax or format or their own grammar or vocabulary or the symbols that it provides, and these are the building blocks of your any programming language. So there are four kinds of these things are called as tokens. All right, token means something which is the smallest unit of a language, and you cannot break it down further. For example, in the English language, you would have alphabets A, B, C, D. You will have punctuators, full stop, comma, etc., and you will have the other symbols plus, minus, etc., which we also use for mathematics. You will have numerical symbols 1, 2, 3, 4, 0, 9 till 9, 0 to 9, and all those things are there. Same way, like it's just like that. If I say A, can you break down A into further something? No. If I say a word, let's say Python, Python is itself composed on few alphabets. All right, you can break it down. So tokens in programming languages like alphabets, these are the simplest units which make up your program. All right, through which you write words, then you write sentences, then you write paragraphs, etc., etc. So there are four kinds of tokens typically in programming languages, and it starts with keywords, identifiers, literals, and operators. So we'll start with keywords. Okay. So keywords are something which are predefined by the programming language, and they have a fixed use that they are assigned, and you cannot change the meaning. All right. For example, I have written a variable over here by the name, let's delete this first. I have written a variable by the name X. All right. And it allows me to do it. But if I say if equal to 1, it doesn't allow me to do it. Also, Jupyter does syntax highlighting. You can see operators are appearing in different color, constants or numbers are appearing in different colors, variables are appearing in different colors, functions appear in different colors. Everything is color coded by Jupyter automatically. Fine. So now when I write this thing, when I say if equal to 1, it says invalid syntax. All right. Why? Because if is a keyword, if it is in the set or the list of keywords available in Python. All right. And what happens is keyword have a predefined meaning. You cannot use them for any other purpose apart from what they are meant to be used for. All right. So they have a predefined meaning. We will see a lot of keywords gradually as we work with Python, but you cannot use it for as a variable. You cannot use it at the wrong place. For example, you have full stop. Full stop has to be used at the end of a sentence. You cannot put it randomly anywhere in the sentence or in the middle of a word. There's a fixed use of it. There's a fixed meaning for it. Question mark has to be used when you're actually asking a question or you're writing a question-based sentence. You're asking something. You cannot use a full stop where you're asking a question. All right, same way, Python has these keywords which have predefined meanings and they have a particular purpose. We'll talk about them. The next thing is when you write any name in Python, for example, when you wrote a variable name, any kind of name which is used to identify something, those things are called as identifiers. All right. And variables or any kind of name that you give to something, it's called as an identifier. For example, when I say x equal to 1, I'm saying that I'll call this value 1 by the name x. So this x is an identifier. All right. And typically, just like we humans have names, all right, or not, let's not talk about that. Let's say you are going to create an account or a Gmail account or some kind of account somewhere. They ask you for selecting a username. Now, when you select a username, they have certain rules. For example, in some places, you're not allowed to put a space. You typically don't put a space in username. All right. They don't allow you to put a space. Some usernames allow you to have a dot inside the username. Some places they don't allow. For example, Gmail allows you to put a dot. I think GitHub maybe won't allow you to put a dot in your username. I'm not sure, but it might not allow. So same way in case of Python programming language, when you create the name of some variable or name of something, there are certain rules of creating that identifier or name. All right. And the rule says that your identifiers can contain alphabets. It can be in capital or small. It can contain numbers also, but you cannot start identifier or a name with a number. All right. You can put underscores inside the name anywhere, maybe even in the start of the name, at the end of the name, and but you cannot put a number in the beginning. You can put it in the middle and at the end, but you cannot put it in the beginning. And you cannot use any symbols apart from these three kinds of symbols inside a name. You cannot put a dot, you cannot put a space, you cannot put slash, You cannot put comma, you cannot put anything else inside a name. You can write names just like this. And another thing is variable names or identifiers or names in general should not be keywords. All right. And variable or identifiers are typically the name of variables, name of classes, name of functions, name of modules. Anything which is the name of something is an identifier. All right. And Python has some special identifiers also which start with 2_ or they both start and end with 2_. These are special things. We'll talk about them later. But these are special kinds of variables. Now let's look at some valid and invalid examples. So this is an invalid identifier. All right. Since something which we comment doesn't get executed, so for invalid, if is an so for invalid cases, I'll just comment that out. So can you have a variable by the name X? Yes. Can you have a variable by the name _X equal to 1? Yes. Can you have a variable by the name _X equal to 1? Yes. Can you have X_Y? Yes. Can you have X1 equal to or any number at the end of something? Yes. Can you have some numbers, then some alphabet, and then something? Yes. Can you have something starting with a number? You can see that the color already starts looking different. This one looks, I'm not sure if you're able to see, but this one looks green and the X is in a different color, whereas all these are all in black. So if I run this thing, it's going to give me an error for this one. So I can comment this out and all of the remaining ones will just work out. All right, so it didn't give me any error. It got executed because I'm not printing anything, so it doesn't print anything. X comma underscore X comma underscore underscore X comma X underscore Y comma S1 comma. I'll leave the last one. It's too long. What happened? Oh, and another thing to notice is I have written capital X over here, and what I'm using over here is small x. So it's saying small x is not defined. And this thing brings me to another point, which is called as case sensitive. So what it means is names which are written in capital versus which are written in small are different. For example, I think if you use Facebook, I'm not sure if it happens right now, but initially if you used to probably type password in capital or small, it doesn't used to matter. Do you guys remember anything like that on Facebook? You enter password in capital or small, both work. I think it used to work. I'm not very sure, but I think it used to work earlier that if you type your password in capital or small, both work. All right. So if something like that happens, it's called as case insensitive. But if you type your password in capital and while entering it again, you type it in small and the system identifies both as different. So that thing is called as case sensitivity. Case means capital or small. So there are two things. One is uppercase. And one is lowercase. Small alphabets or capital alphabets, and that Python identifies both as different. So if I say x equal to 10 and then I say capital X equal to 20 and then I say print x comma capital X, both are treated as differently, and Python knows the difference between two. And the same way Python also knows the difference between this. I can use capital IF equal to 10, IF equal to 10, and IF equal to, let's say, 20, or let's call it 30, and all of this would work out. Why? Because all these are not keywords. The keyword if is always written in small, so all this will work out. It won't give me any kind of error. Cool. So this means Python is a case sensitive programming language. It knows the difference between capital and small alphabets, and yeah, that's about this thing. I think I'll need to reload. This is a slight bit of problem. Oh, this looks good. Cool. So do you guys have clarity now about case sensitivity and identifiers, what they are? Identifiers are names. They can be the name of a function. For example, print is what? Is it a keyword? or is it an identifier? What do you guys think? This print I have been using till now for printing things. Is it a keyword or is it an identifier? Does Python already know what print does? Or does it have a predefined meaning for print?
Be a keyword.
Sorry?
A keyword is keyword.
Print is a keyword. All right, let's go and check if it is in the list of our keywords. Do you find print over here? Yes, no?
No.
No? So is print a keyword? No. So if it is not a keyword, it is an identifier. And if it is an identifier, can I use it for storing something else? Like right now, print is what? Print is a function which prints something, all right? And let's do something weird over here, all right? I do too many spelling mistakes. All right, and I say x equals to 10, then I say y equal to x, and then I say x equal to 20, and then I say print x comma y. What would be the output? Tell me quick, make it fast. Is it going to be 20, 20, 10, 20, 10, 10, or 20, 10? Four options are there. What happens?
2010.
Sorry,
2010.
2010. That's correct. Why? Because when you say x equal to 10, x is 10. When you say y equal to 10, now both y and x are pointing to the same data 10. Then you say, hey, x, I want you to point somewhere else, but does it change y? No. So x becomes 20, but y stays 10. So this is the output. Cool. Now let's look at another thing. If I just say print of print, do you think it will work? What is print actually? What did I tell you guys that what is print?
Print is a function in Excel.
Yeah. So if I run this actually works in Python. Because in many programming languages, things like this might not work. All right. But what it tells you is that print is a built-in function. All right. But is this print a keyword? No, we know now. All right. So this is an identifier. And if it is an identifier, can I play around with it? Something like p equal to print. So what does p become now? Are p and print the same thing now? What do you think? Yes or no? Actually, I should do this in the interpreter. P equal to print. What is print? Print is the function. What is p? P is the same function. Now, if I say p bracket 10 plus 20, is it going to work? Just no, no,
No.
it works. Cool. Now, can I say print equal to type? It works. Then I say what? Type equals to p. Now, what is print? Print is type, and type is print. Now, I can say type of print of 1 or 10, and it works. Why? Because these names, these function names are also identifiers. All right. You can treat them as variables. You can say print equal to 10, and then you can say p bracket 10. But now when you say print bracket 10, it won't work. Why? Because print is now an integer. It's no longer the built-in function, and it will give you an error. Int is not callable. Why? Because print is an integer now. Can you ever write x equals to 10 and x is an integer? X is not a function, and functions are called like this. You can put a bracket, and this is called as function calling, and you can put some value over there, and it doesn't work. Why? Because integers cannot be called. It means this is an integer. This x is an integer. And you will many times find this kind of error. So it basically means whatever X contains, that is an integer, but we are trying to use it as a function. But since print, etc., all these are identifiers, they are not keywords. You can reuse their names, but is it good to do this? No, it's like confusing code. I think you guys might have got confused by all that I wrote, but this shouldn't be done. But remember, this is possible. And sometimes if you do it by mistake, it's going to give you weird errors. You'll think like, why is it giving me this int not callable when I'm saying print? Because by mistake, print might have become an integer or maybe something else. You don't know. By mistake, something can happen. So it's also important to understand what kind of errors typically Python tells you. So it says int is not callable. It means you are trying to call an integer or you're trying to treat an integer like a function. That's the problem. So it helps you understand how things are working in Python. Is this somewhat clear now to you guys? You will never find anyone writing this kind of code, like changing the meaning of print or something. All right, but this happens by mistake. A common mistake that everyone does, even I do in Python, is there is a function in Python called as sum. All right, and if I say, my bad, if I write something like this, I don't want to tell you what this extra bracket is, but it's going to add these two things. It's going to add 1 and 2. Sometimes what we do is we write something like this: sum equals to 1 plus 2. Now is sum the function that we were using? No. What is it now? It's now an integer. All right, sum. And this is a very common mistake. Even I have done this a lot of times. Why? Because when you have to store the sum of something, typically we call the variable itself as sum. Why? Because it's intuitive. But there is a thing that Python itself has a built-in function by the name sum, and that gets overwritten. That's why I wanted to show you this example of what might happen with Python. All right, because function names can be reassigned in Python because they are just identifiers in Python. In other programming languages, that might not be the case. For example, if you do something like this in these languages, it's going to give you a syntax error. It's not even going to compile. All right. Whereas in Python, all this works somewhat fine. Cool. Got the idea, guys? Is this clear? Or did it spin your head completely? Do you guys want to try it out? Or is it fine if I move? Actually, I think what else is there? There are a couple of things actually, but tell me, does this look good? Do you want to try it out on your system? Maybe I have done some magic on my system and all this is working and your system might not do this. Do you guys want to try out? No? Yes? Let me know, guys. Do you want me to explain something? If you don't understand, tell me. All right, so guys, let me know what should I do. So I'll assume that all this is good then. And this is on my interpreter. It's not on the Jupyter notebook. On Jupyter notebook, it's just this thing. I'll be uploading this on your GitHub and I'll show you what all this, like, I'll not push it today on GitHub, so you won't get it right now. You will get it from tomorrow onwards. So I'll show you how to push things on GitHub, etc. from tomorrow. But yeah, this will all be available to you. But whatever I have put on the interpreter, that's not on the notebook. All right. If you guys want me to paste that somewhere, or you want me to give all this to you, or you want me to type this on notebook, let me know. Otherwise, the video is there for sure for you to refer again. Cool. So coming back to the PPT. So we have talked about two things now: keywords and identifiers. I just want you guys to read this thing again. And I'd already mentioned that function names are also identifiers. So that was an identifier. Just read through this again and I'll wait for a minute. Fine, guys, looks good. Then we'll move on. This PPT also will come on GitHub from tomorrow onwards, not today. All right. And okay, this thing is something important. There's a problem with this double clicking doesn't select properly. So I'm going to put this link on your displays. And I want you guys to read about this, not today, tomorrow, whenever you have free time. It's not needed right now immediately, but I want you guys to be aware of this thing. And this is a thing for you guys to do yourself. All right. Next thing is, we have 4 kind of tokens. Like your program is built of everything that you write in code is built of these 4 things. There's nothing outside of these 4 categories. So the third thing that comes up over here is called as literals. Literals means the constant values or the fixed things that you are writing. For example, we have already seen integers. If you write 1 is if 1, you cannot transform 1 to 2. 1 is 1, it's a constant value, it's a fixed value, and these things are called as literals. And there are different kinds of literals: integer literal, float with decimals; string literals, things which are written in quotes or pieces of text. They can be written in single or double quotes. We'll come back to that in more detail later. And there is another category called as Boolean. Boolean means true or false. Just like we had 0 and 1 in binary, same way Boolean has just 2 values, true and false. And true and false are actually keywords. If you would notice, the first 3 keywords, they are in capital: false, none, and true. And apart from them, all the keywords are written in small. Apart from these 3, only these 3 have their first alphabet capital. All right, and there is a special literal called as null. Null means empty, or what is the notion of null in other programming languages? Null. Same thing none denotes in Python. If you want to say something is empty or it doesn't have anything, it's none. It's a special type. All right, and it doesn't have any other value. It's just none. It's called as none type. Fine. So these are the 5 kinds of literals. There are, I think, a few more, 1, 2, or something. But these are the important ones. All right. And we have been using literals since the beginning. 1 plus 1, that was 2 literals over there. All right. Then we come to operators. Operators means something which do some operation. It can be arithmetic operation, like 1 plus 2, it's an arithmetic operation. 1 greater than 2, it's a logical operation. It tells you whether not logical, it's a relational operation. Relational means it tells you whether 1 is greater than 2 or not. So it tells you a result, true or false, something like that. And same way, normally when we see operators, we typically look in the form of symbols. Slash means divide, star means multiply in programming. So in programming, you have to write star for multiplication. Star is for power. We'll see examples. And there are special operators in Python which are written in the form of text: in, not in, is not, and not, and, or, and all these things are there. Greater than, equal to, greater than, equal to, less than, equal to, not equal to, equal to, equal to, all this stuff is there. We'll see examples of all this, but these things are called as operators. And this is the last or the 4th kind of token that you have in a program. All right. Now, and we have already talked about comments. We'll come back to this thing, but now if you look at all these pieces of code that we have written till now, if you look at this piece of code, can you tell me under which category of tokens X falls? What is the type of X? What kind of token is X?
Identifier.
It's an identifier. Cool, that's correct. All right. Then when you see equal to, what is equal to? What kind of identifier it is?
Operator.
Operator. Then what is 1?
The literal.
A literal, integer literal, or we can say literal. Same way, if you look at all this code, all of this belongs to like some, it's some kind of token. We haven't written any keyword over here. That's the only thing. We have all the other 3 kinds of tokens. We have identifier. So print is an identifier. It's not a keyword. What is this bracket? Bracket is an operator. What is this comma? Comma is also an operator. All right. X, Y, and Z, what are they? They are identifiers. So every piece thing that you write in code is belonging to those 4 categories. All right. And the last thing that you see is comment. Comment is not related to code, like it doesn't get executed, but it is actually related to code, like it describes something. And just read about this thing. Take a quick look at this thing. All right. And there are like articles about comment, how to write a comment, what is a good comment, when you should write, when you shouldn't write. And there is a complete theory on that itself. All right, so comments are also important in code. It's something that typically when we start to learn programming, we just ignore it. But from a software product or an application or a project perspective, comments are important. And there is something called a self-documenting code. There's a lot of best practices while writing code. It's just like when you probably for other things inside the world also there are best practices. Let's say you have a vehicle, how you should maintain the vehicle, what are the best practices. Same way for code or writing code, also there are best practices, and there are a lot of things around that gradually stick. Cool. So you guys understand that whatever is on the right hand side of hash is going to get ignored, not what is on the left hand side of hash. Cool. And what next? There is another DIY, and I don't think we are going to talk about Python path right now. It's something that is needed for something later. But I think this is also something relevant which will come later when we talk about classes and functions. But I'll still post this link if you guys want to have a look. Just have a look and just see what this means. I'll tell you again to have a look into it when we talk about functions and classes, but I'll let you know when that's needed. For now, this thing you can just have a look if you're interested in it. Cool. So yeah, guys, I think for today, I think that's most of it. I think we'll continue from here tomorrow. All right, and now tell me if you guys have any questions. Otherwise, I think we'll close 4 minutes early. Yeah. Anything, guys? And did you guys understand it, or how did you feel, or was it something you already knew, or very easy? It might be easy. Probably if someone teaches me this, it will be very easy for me, even for other programming languages. But saying, okay, for you it was new. All right, yeah, for you it would be new. Cool. What about you guys? Dilip, Pratap, and Diksha, will start. Okay.
Yeah, bro, for me it's new, like fully new. Like only the print other than everything.
I don't know why, sorry, Pratap, but your and Dilip's voice is somewhat like going, and it's like you guys are talking in a hall. You're sitting in a big hall, and
Yeah. My mind is like alien kind of voice.
okay, your voice is somewhat more clear than Dilip for me, but at least I'm getting what you're saying.
Yeah.
Okay, guys. So let's see. Cool, guys. So this PPT and all I'll share. I don't think you guys would be interested in the PPT because it's just a sequence or the order in which I have to talk about things, but it's not actually the entire thing. The best place to look for anything is obviously python.org or docs.python.org, my bad. And Python keeps on getting updated, guys. Like it's getting updated at a very high frequency, and it's difficult to catch up with what is getting released new. And you can probably, whenever a new version gets released, you can probably look into what's new in Python something. All right, and you'll get to know what's happening. So you can see on the left hand side it says docs by version. Python 3.9 is stable and it's released already. There is Python 3.10 which is already released. It's a pre-release. All right, and the next version is already in development. So you can read the documentation or what's new inside a particular version, or what's new is being released. You can look into that particular thing. All right, and it's a good thing. Even I myself don't come over here frequently. I come over here only when something in a particular version doesn't work. Only then I come up over here. Otherwise, I don't come. But if you want to dive deeper, then it's a good place to come up and have a look into things. All right, so it's python.org, what's new, or what is there in a particular version. And yeah, it's good actually.
Gaurav?
Yeah.
So who does all this updation? Is there a separate entity doing all this updation?
So there is a community behind Python. I cannot explicitly I haven't myself said who is doing this. So typically what happens is big organizations support these kind of projects. All right. So there will be a committee around this thing, which would involve people from the industry. So let's say there is a thing that you want improved or a new feature that you want in Python. Let's say you have a very good feature in some programming language and you want that to be available inside Python. So you write a proposal and you would write a document about it, like what will change, how it will be kind of implemented, what should be there. And then there is a committee which decides whether that feature can be accepted, whether it will be rejected. If it is accepted, in which version it can be picked up, how good it is, what the implementation would be, and like that things happen. And there's a body which would do all that stuff. And the people who work on this, they can be contributors, they can be people like you and me who are interested in improving Python. All right. Or it can be people who dedicatedly work on this thing. So there is a different way these softwares are built, and they are mostly supported by organizations, big organizations. You would typically see that on for some language or for some tool or any platform, they would typically see who are the people supporting the development of that particular thing. So it happens like that. Even we can contribute to this thing. It's possible. For example, if you go to where you can see there are 1.4K or 1,400 pull requests. Pull request is something like someone wants to improve something. They have created a change in the code, and now someone has to approve it and add it to the main code. So this is the way things work out. You can see that a lot of people are fixing things, fixed PDBs, arguments, and retrieval command, something. All right. PDB is Python's debugger. So allow compiling on Debian or Ubuntu with a different compiler. I don't know what this even means. So you can probably go look into this, what is happening, how these people are actually contributing, and you can see there is a cross or a check mark before or after something. So this typically tells you, so whenever someone makes a change, there are certain automated tests that run on a particular piece of code that check whether the change that you have introduced, does it cause any issues in the existing behavior? So all that is taken care. And you can see under actions, there is an automated action or a test which is running. All right. And this test will check a lot of things. So they are checking the build on Windows 86, on 64, on Mac OS, on Ubuntu, and they're doing a lot of tests over here. Cool. So it's a process in itself. The people build this entire setup or build this entire process for all kinds of projects. I was thinking there would also be a thing for issues over here, but there is no issues over here. Probably they manage the new issue, something, the issues somewhere. Let me search for it. Okay, issues is here. I am not sure if it will. It says GitHub issues. So this is for me. This is my personal accounts thing. And this is not the issues for this particular repo. So probably if you search for, you look at this contributing to C Python. So they are saying that you can look at the developer guide. All right. And you can go over there and see how they are doing stuff over there. They will tell you about this thing. So you can write documentation for Python. Maybe you don't want to contribute code. You can write documentation. That's also a good way of contributing to open source projects. I have myself never done it, but people do. So there are a lot of things. It's dev guide. And thanks for asking this question. I have myself never come up to these pages. I know how to reach them, but I never did that myself. Too lazy for that, but this is how you can navigate things. So if you go to a GitHub repository, you would have noticed that how did I search for things? I knew that typically repositories, if you go to GitHub repository, they typically have this section called as contribute. So I just searched for contribute, and this brought me to this thing. And this is how you gradually learn about how repositories are structured, where to find things. All right. And normally they would call documentation as documentation, and they have an issue tracker. You can see there's a bugs.python.org, and they have literally everything. And yeah, you can see there are so many issues. If you're interested, probably you can pick one up and fix it. Yeah, that's what community service.
So
if you have
fix it, they're gonna pay for that.
I'm not sure. That you'll have to check. Because they'll have maybe. But I think if you are interested in getting paid for fixing this thing, it's going to take a lot of effort to learn how to fix that bug, because Python language by itself is written in C
Of course,
programming
yeah.
language. And learning the code base of Python will take time.
Just kidding.
No, but can do anything. See, I believe that anything can happen. If COVID can happen, anything can happen. So probably you can contribute, and I'll be happy. Yeah. But there's a lot of things you can explore, and you can see it. It allows you to log in and create account and all that. There is a user list who are the administrators for this thing, and there is a community section. Probably they talk on some kind of Discord or something, or maybe they have Slack group, something. Yeah, they have Discord, they have Slack. Maybe you can join it, pythonweekly.com or something. There are a lot of things over there. Cool. And from a data science perspective, see, there will be, in general, like, I'm not sure if you guys read some blogs or something. Like, typically there are some famous data science blogs or websites, something like that, and you can find there are a lot of those things. So this towards data science is something which comes up always, and this is an article about the top 20 blogs. So you can probably look if you find something interesting. After that, gradually you'll find some good websites which will keep coming up again and again. You can probably subscribe to their feeds and all that, and it's good. It's literally good if you do that. All right. And they say on their blog that the best blogs to follow, and the number one is their own. So they have a list, but on top definitely they put themselves. So that's good. You can probably follow some of these. Data Science Central, Data Science thing, something. Data Science on Reddit. It's good to get into these kind of community. Cool. There's Google News also for data science. Nice. Good question. Cool.